Good day to all. Today we are going to see about the topic of valves. What are the types of valves in that pneumatics? First one is servo valves. Servo valves, it's complicated in the structure and also it is have a more efficiency. But the main advantage is here in the servo valve, which is a good control. You can control easily. And next one is the proportional valves. It is construction wise simple as well as cheap, robust, as well as the main disadvantage is that in that proportional valve it is more difficult to control. And digital hydraulics, there's several fast on off valves and digital control valves. These are the valves in the pneumatics. Then actuator cylinders. The types of actuator cylinders are: first one is a single acting, then double acting. The main types of these actuators are first single acting and double acting. Now we see about one by one in the single acting as well as in the double acting. See, in that single acting you can see work done can be done in only one direction, either this direction or this direction. See here in the diagram, it arrow indicates that if the pressure is coming here, then the piston move depends upon that air pressure come into that particular system. This is the plunger type cylinder, and this one is piston type cylinder. If it is air coming means according with that purpose, then it will move. This one is a telescopic cylinder, and this is a fast moving cylinder. Now we will going to see double acting cylinder. Here it will move up to this side as well as this side. Here it is shows only one direction, A, but whereas here it shows two direction, A as well as B. And here this shows that piston rod on both sides. See here in that single acting cylinder there is only one rod, but here there is a two rod, here as well as here. This is a piston type, and this one is tandem with the double acting cylinder. Here the telescopic with the double acting, and the fast moving also it's have a double acting one. This is the operation of that particular valve. Here it shows that valve responding to charge in that electrical input. Here valve conducting flowing the charge. The comparison of electrical and fluid actuators, this we are going to see here. See here in that electrical system, a battery generates a voltage which is basically an electrical pressure. Then the voltage pushes a flow of electric charge through the wires. The voltage driven flow of current, the voltage driven through flow of current through an electric motor or other electric device can be used to perform useful work. The flow of current can be controlled with the switches. This is in that electrical system. If you are going for a hydraulic system, a hydraulic pump generates a pressure in a fluid, as well as the pressure pushes a flow of liquid through the tubes and hoses. The pressure driven flow of liquid through a hydraulic piston or other hydraulic mechanism can be used to perform a useful work. The flow of hydraulic fluid can be controlled with that valves. These are the comparison of that electrical and fluid. Here it's a simple hydraulic system can be made out for syringes and a aquarium tube. This is the ROE with the hydraulic actuators, and the application of that hydraulic actuators are we are investing of this hydraulic actuator to provide a strength, speed, and compliance need to for a human-made robot. We conduct an analysis of hydraulic joint hip pitch of humanoid robot. The advantage and disadvantage of this hydraulic actuations. The actuators mainly are small relative to the power they provide. This allows limbs to be strong and lightweight. But the oil must be routed to each actuator through the hydraulic hoses. If the hoses are not large enough, then speed and strength may be limited. So here the length of the hose must be large. That's a main disadvantage here. And there must be a exist pump to supply a high pressure valve. The pump should be always there to give a pressure to that oil, then only it will work with very good efficiency. And this one is the pneumatic cylinder. The operation of a pneumatic cylinder here is it's a Fisher-Sink pneumatic cylinder. It can be moved in both inward as well as outward by the compressed air. The cylinder of this type are called double action cylinder. As we see before in that actuator, single acting, double acting. Likewise here the pneumatic cylinder have a two type, inwards as well as outwards. This will operate according to the given air. Okay. The cylinders also exist with can only be moved pneumatically in one direction. The return movement is caused by a spring. The cylinder of this type is called single action cylinder. The compressor cylinder is in single action cylinder. See here it's a double acting cylinder and it will have a inwards as well as the outwards, both direction, inward direction also and outward direction also with compressed air. Why here it's working with the compressed air? Because it is a pneumatic. As I said before, if it is a pneumatic, the main work will be takes place with that air. Whereas in hydraulic, the main work will takes place with that oil. So here the compressed air with work according with the application whether we want to go inward or outward. Here in single action there is a only one movement, that is called the single action cylinder. In order to move a Fisher-Sink cylinder in both direction, two of the valves contain kit are required. That's the main thing in that Fisher technique pneumatic cylinder. Here in that pneumatic cylinder, see this is the diagram of this pneumatic cylinder. We can see now it will go to inward. If you want to give air to the last position of that particular system, then we will get the output of the this pneumatic cylinder. Thank you.